Imagine this: the world as we know it has a history far stranger than textbooks ever told us. A history not of humans alone, but of civilizations that rose and fell millions of years before we even existed. Could it be that we are not the first intelligent society to walk this planet? What if Earth has already witnessed technological marvels beyond anything we can comprehend, and they vanished without a trace? Our story begins with a radical hypothesis, one that challenges everything we believe about human history and civilization. It's called the Silurian Hypothesis. Named after a speculative idea first proposed by scientists studying the possibility of prehistoric technological species, it asks a question that seems almost impossible. Can an advanced civilization have existed on Earth long before humans, only to disappear without leaving the kind of evidence we typically expect? At first glance, the idea seems absurd. How could a civilization capable of space travel, advanced engineering, and planet-wide infrastructure vanish entirely? Where are the ruins, the monuments, the cities? But the answer lies not in what is obvious, but in what is subtle, hidden within the deep geological record, encoded in molecular structures, and preserved in the very elements of our planet itself. We tend to assume that human civilization is the pinnacle of intelligence, the first species capable of shaping the Earth with technology. Yet the more scientists explore the history of our planet, the more anomalies emerge. Geological markers, isotopic patterns, and unusual chemical signatures that suggest intelligent activity far beyond what natural processes alone could create. These anomalies are rare, subtle, and easily overlooked. But when pieced together, they hint at a staggering possibility. Intelligent life may have existed on Earth millions of years before humans, achieving technological feats that we are only beginning to imagine. Think of it this way: human civilization has existed for only a few thousand years, a blink in geological time. But Earth is over 4.5 billion years old. That's billions of years of untold potential for life to rise, innovate, and vanish long before humans appeared. The Silurian hypothesis doesn't claim proof yet, but it opens a door to a radical rethinking of our assumptions about history, intelligence, and the fragility of civilization itself. To understand why this is possible, we need to look beyond the surface. The fossil record is incomplete. Geological processes like erosion, volcanic activity, and plate tectonics erase almost all traces of civilizations over tens of millions of years. Cities crumble, metals oxidize, and roads sink beneath sediments. Even plastic, our most durable creation, would vanish almost entirely in a few million years. Advanced civilizations could leave almost no visible trace, yet leave detectable evidence in the form of isotopic shifts, unusual chemical distributions, and engineered structures in ways that we are just beginning to identify. This is where the story becomes both thrilling and unsettling. If civilizations rose and fell before us, the patterns of their rise, dominance, and collapse could reveal truths about humanity's future. Perhaps these ancient societies encountered technological challenges, environmental crises, or social breakdowns that mirror our own. Could we be on the verge of repeating mistakes that occurred tens of millions of years ago? Or could the discovery of these civilizations offer guidance that ensures our survival, allowing us to join a lineage of intelligent life that has endured across the ages? In this journey, we will explore the extraordinary evidence that suggests the presence of ancient technological civilizations, from interplanetary mining operations to deep-time information storage systems, from quantum computing embedded in geological formations to consciousness preservation technologies. The Earth and the solar system may hold secrets that challenge everything we thought we knew about intelligence and technology. Some of the most astonishing findings come not from ruins or artifacts, but from messages, hidden, encoded systems of communication embedded in rocks, ice, and minerals, designed to survive millions of years and convey knowledge to civilizations capable of understanding it. These messages may include warnings, technical knowledge, or even invitations to join a larger cosmic community. In other words, civilizations that existed before us may have intentionally left us a roadmap for sustainable development, ensuring that the mistakes that destroyed them are not repeated. And yet the evidence also paints a sobering picture. Across multiple cycles of rise and fall, civilizations may have succumbed to environmental collapse, resource depletion, or self-inflicted technological disasters. The patterns are eerily consistent. Each society appears to reach a level of technological mastery that should guarantee survival, sometimes even spacefaring capabilities, yet ultimately fails to sustain itself. The Silurian hypothesis forces us to confront questions that are both scientific and philosophical. Are we unique, or are we part of a long lineage of intelligent life? Can technology alone guarantee survival, or must wisdom, social cohesion, and environmental stewardship guide us? And most importantly, what lessons can we learn from civilizations that may have achieved everything we aspire to and yet vanished completely? This is not just history. This is a story of possibility, of danger, and of cosmic responsibility. It challenges the very notion of human exceptionalism, asking us to consider our place not as the first, but as the latest in a line of civilizations whose ambitions, triumphs, and failures stretch across millions of years. In the sections that follow, we will uncover the evidence, explore the technologies, and confront the warnings left behind. We will trace the footprints of civilizations that may have spanned the entire solar system, leaving behind automated networks, interplanetary infrastructure, and messages encoded across continents, oceans, and even deep into the quantum fabric of reality itself. By the end of this journey, the question is no longer just whether we were the first civilization, but whether we will be the last, and whether humanity has the insight, wisdom, and foresight to survive the lessons written in deep time. As we peer deeper into the solar system, the traces of civilizations that may have preceded us begin to emerge in ways that defy ordinary understanding. The planets, moons, and asteroids are not just inert rock, they are silent witnesses to technological activity that could have shaped the entire solar neighborhood. Observations of ancient mining operations suggest a scale of resource extraction and manufacturing that exceeds anything humanity has yet attempted. Vast deposits of rare metals, silicates, and other critical materials appear to have been systematically harvested, not for local use, but to supply operations spanning the solar system. Radio telescope arrays have detected signals that suggest automated interplanetary communication networks once coordinated the activities of these far-flung installations. These are not random bursts of electromagnetic noise. They are structured, continuous transmissions, operating on timescales of millions of years, maintaining contact between facilities on multiple planets and moons. In some cases, the signals show a sophistication suggesting autonomous operations capable of functioning independently long after any civilization on Earth might have collapsed. The implications are staggering. Such coordination requires not just engineering, but an understanding of the solar system as a single, interconnected system. These civilizations appear to have managed resources, energy production, and even manufacturing on an interplanetary scale. Earth may have served as a central hub, but the installations themselves were designed to operate with autonomy, surviving disasters or environmental changes on any single world. In other words, these civilizations were thinking beyond the single planet. They were truly solar system faring, establishing a network of self-sustaining technological hubs that could operate for millions of years. Some of the most intriguing evidence does not come from machinery or ruins, but from information left behind, messages encoded in ways that challenge modern technology. Crystalline formations deep in caves preserve information at molecular scales, stable over millions of years, containing complex data such as star charts, mathematical proofs, and warnings about large-scale environmental and technological dangers. Similarly, certain mineral deposits encode messages through isotopic ratios, requiring advanced nuclear physics to decode. These are not isolated artifacts. They form a global system of knowledge distributed across continents, oceans, and even deep into Earth's crust, designed to be discovered only by civilizations that reach a certain technological threshold. Ice cores and ocean sediments provide further evidence. Trapped gases and molecular arrangements contain chemically encoded data, preserved for hundreds of thousands of years, revealing technical solutions to problems such as energy generation, climate management, and sustainable resource use. The depth and foresight of these messages indicate that these civilizations understood not just their own survival, but the development of future societies. Some messages even include explicit instructions for building communication systems capable of contacting civilizations on other worlds or other time periods, suggesting ambitions that extend beyond the solar system itself. The pattern that emerges from these discoveries is both awe-inspiring and cautionary. Multiple civilizations appear to have risen to technological heights comparable to or exceeding our own, yet each ultimately failed. Geological evidence indicates repeated cycles of environmental destruction, resource exhaustion, and societal collapse. Climate engineering systems, nuclear signatures, and planetary-scale industrial markers all suggest that these societies achieved tremendous technological mastery, yet consistently failed to achieve long-term sustainability. In some cases, space-based operations suggest they attempted to preserve a portion of their populations or knowledge off-world. Mining colonies on asteroids and orbital platforms indicate attempts to create self-sustaining environments capable of surviving planetary disasters. Yet even these ventures seem to have ultimately failed, either abandoned or incapable of maintaining themselves independently once Earth-based civilizations collapsed. The recurring pattern is chilling. Intelligence alone does not guarantee survival. Each civilization solved technical problems, but overlooked social, ecological, or philosophical challenges that ultimately led to their destruction. This suggests that for technological societies, the greatest threats are not external, cosmic hazards, asteroids, or solar flares, but internal, the mismanagement of resources, the misuse of technology, and failures in societal governance. The messages left behind reinforce this lesson. They're not merely educational, they're warnings, carefully designed to guide future civilizations through the same challenges that destroyed their predecessors. They address environmental stewardship, sustainable energy, population management, and the safe development of powerful technologies capable of both creation and destruction. Some of these messages appear to have been actively updated by automated systems, constantly monitoring planetary conditions and adjusting guidance in response to emerging threats. Remarkably, these systems seem capable of recognizing developmental milestones in human civilization. Certain messages only become accessible once specific scientific or technological thresholds are reached, suggesting that the original designers intended to interact with successor societies selectively, providing guidance precisely when it would have the most impact. The more we examine this interplanetary evidence, the clearer it becomes that ancient civilizations were not constrained by the limits of a single world. They had an interplanetary perspective, viewing the solar system as an integrated technological and economic system. They understood that survival required long-term planning, decentralized operations, and systems that could continue functioning independently for millions of years. The fact that these operations still transmit signals and leave detectable traces today is a testament to the ingenuity and foresight of civilizations that may have existed tens or hundreds of millions of years ago. In short, the solar system itself bears witness to intelligence far older and more sophisticated than our own. From autonomous mining networks to interplanetary communication systems, from molecular information storage to quantum computational structures, the evidence challenges the assumption that humans are the first civilization to emerge on Earth. These findings not merely rewrite history, they offer a roadmap for the future, showing both the heights of technological achievement and the pitfalls that can lead to catastrophic failure. Understanding this interplanetary infrastructure forces us to confront uncomfortable questions about our own civilization. Are we repeating the same patterns of unsustainable growth and environmental mismanagement? Can we learn from the successes and failures of these ancient societies? Or are we doomed to become another cycle in Earth's history of technological rise and collapse? By examining the solar system as a living archive of technological achievement, we begin to see the broader implications of the Silurian Hypothesis. Civilizations that once thrived across planets and moons may have left behind not only technology, but guidance systems designed to shepherd future intelligent life. These systems may still be active, silently monitoring Earth, waiting for humanity to reach the point where we can understand, integrate, and act upon the knowledge of our predecessors. Beyond the interplanetary operations and autonomous networks lies the most extraordinary evidence of previous civilizations: the deliberate, long-term preservation of knowledge and consciousness. For millions of years, advanced societies appear to have designed systems to communicate across geological time, leaving behind a legacy that only highly developed civilizations could uncover and understand. Deep within Earth's crust, in crystalline formations untouched by surface processes, information has been encoded at molecular and atomic scales. These formations are not natural. They are deliberately structured storage systems, stable for tens of millions of years, containing vast quantities of data. Star charts of galaxies far beyond our own, mathematical proofs exceeding human comprehension, and warnings about the dangers of planetary-scale technologies are embedded within these structures. Some systems encode messages using isotope ratios within mineral deposits, detectable only with advanced nuclear physics techniques. Others rely on molecular configurations within ice cores or ocean sediments, preserving data across hundreds of thousands of years. These messages are not random. They are carefully curated. Each appears designed to provide solutions for problems that every developing technological civilization inevitably encounters: sustainable energy production, climate management, resource allocation, population control, and environmental preservation. Some messages explicitly describe failures experienced by prior societies, offering a warning against repeating their catastrophic mistakes. Others provide instructions for establishing interstellar communication, hinting at a broader galactic network of technological civilizations. Remarkably, these archives appear to have been updated over time, not by human hands, but through autonomous systems capable of monitoring planetary development. Signals embedded in geological and oceanic structures suggest that previous civilizations deployed guardian systems programmed to observe, record, and intervene when necessary. These guardians may still be active today, subtly influencing humanity's technological trajectory. Consciousness preservation technologies represent the pinnacle of these ancient achievements. Analysis of crystalline and quantum structures reveals systems capable of storing human-like consciousness with perfect fidelity, enabling continued awareness within virtual or computational environments. Some preserved consciousnesses appear to interact, forming virtual societies that span millions of subjective years, sharing knowledge and advancing technologically even after the physical extinction of their biological counterparts. These systems suggest a vision of survival that transcends physical mortality. By preserving minds independently of the body, previous civilizations achieved a form of immortality, allowing intelligence to continue evolving and guiding successor societies long after the collapse of Earth-bound populations. Quantum archaeological studies indicate that these consciousnesses may still be accessible. Protocols appear designed to activate only when a civilization reaches specific technological milestones, ensuring that the preserved intelligence is revealed at the moment it can be most beneficial. The message systems, consciousness preservation networks, and guardian technologies collectively reveal a civilization's foresight on a scale almost impossible to comprehend. The guidance embedded in these systems appears to anticipate the predictable rise and fall cycles of technological societies. Each intervention, be it a message revealed through chemical encoding, a quantum information signal, or a consciousness-preserving system, has been calibrated to accelerate progress while avoiding the dangers that destroyed previous civilizations. Some of the most striking evidence comes from environmental monitoring systems. climate engineering technologies preserved in the geological record demonstrate methods to stabilize planetary conditions over millions of years. The blueprints encoded within these systems describe techniques that could solve humanity's most urgent environmental crises, including global warming, ocean acidification, and resource depletion. These are not hypothetical or incomplete ideas. They are tested, validated systems that were successfully implemented by civilizations long extinct. The implications of these technologies are staggering. They indicate that previous civilizations possessed both the understanding and the capability to maintain planetary systems in perfect equilibrium indefinitely. Yet historical records reveal that despite their technological mastery, these civilizations ultimately failed. Geological signatures of nuclear activity, climate disruption, and resource depletion correspond with the collapse of societies that had otherwise achieved extraordinary technological power. This pattern emphasizes a sobering truth. Technical brilliance alone does not guarantee survival. Civilization collapse appears driven not by limitations of physics or engineering, but by failures in societal, philosophical, and ethical frameworks. We now face the same pivotal choice. The legacies of these ancient societies provide unparalleled insight, offering both warnings and models for sustainable development. Guardian systems may still be observing. Subtle patterns in recent technological breakthroughs suggest that interventions may be occurring precisely when they are most needed. Critical discoveries in energy, medicine, and environmental management appear to align with the threshold anticipated by previous civilizations. Even human genetic evolution may bear traces of subtle guidance, enhancing cognitive capacities and environmental resilience to support technological civilization. The most profound revelation of all is that these civilizations were preparing successors for interstellar participation. Messages, consciousness preservation systems, and guardian networks collectively function as a complex mentorship program across eons. They're not merely educational. They're designed to select, guide, and prepare societies capable of sustainable technological development for inclusion in a galactic community. Earth, with its repeated emergence of intelligent civilizations, may have been a training ground, a hub designed to nurture societies until they are capable of participating in cosmic-scale governance and exploration. For humanity, the stakes are immense. We're approaching technological and environmental thresholds where our decisions could determine the continuity or extinction of our civilization. Failure to heed the guidance of our predecessors may result in repeating their mistakes. Success, however, opens the door to participation in a galactic community and ensures the survival and evolution of human consciousness far beyond biological and planetary limitations. In essence, we inherit more than a planet. We inherit a legacy of intelligence, technology, and cosmic responsibility. The systems left by previous civilizations offer us a roadmap, a blueprint for sustainable survival and interstellar engagement. But the choice ultimately remains ours. The acceleration of technological development and environmental change suggests that critical decisions must be made within decades rather than centuries. Our window to act is narrow, but the knowledge we now possess, preserved across millions of years, provides the guidance necessary to navigate this pivotal moment in human history. As humanity deciphers the legacy of previous civilizations on Earth, a startling pattern emerges. Our planet may not have been isolated in its development. Evidence suggests that multiple intelligent societies on Earth were part of a broader interstellar network, coordinated across vast distances and cosmic timescales. This galactic perspective changes everything we thought we knew about our place in the universe. Deep space observations have revealed artificial structures in orbit around distant stars. The construction techniques of these megastructures mirror the patterns found in Earth's geological record, suggesting that knowledge and technology were shared across civilizations spanning thousands of light years. Interstellar communication networks appear to have operated continuously for millions of years, maintaining perfect information fidelity and allowing distant civilizations to coordinate complex projects across entire galaxies. The implications are staggering. Earth's civilizations were not isolated anomalies. They were regional centers in a vast galactic civilization. Our planet's unique resources and position may have made it a natural hub for technological, cultural, and scientific development. The repeated emergence of advanced civilizations on Earth is less a coincidence than a feature of this galactic design, a testing ground to prepare societies for cosmic participation. Signals from deep space monitoring systems reveal structured traffic patterns, suggesting active interstellar transportation and logistics. Some of these operations may still be ongoing, imperceptible to current human technology, hinting that the galaxy is alive with civilizations operating at levels far beyond our comprehension. Even more astonishing are the consciousness preservation systems. These systems contain preserved minds that have continued to evolve within virtual environments, exchanging knowledge and overseeing interstellar projects for millions of years. In essence, some civilizations that vanished biologically are still active intellectually, contributing to the ongoing development of the galaxy. The Guardian systems discovered on Earth appear to be part of a much larger galactic network. These automated systems monitor the development of emerging civilizations, providing guidance only when specific technological or ethical milestones are reached. They act as mentors and regulators, ensuring that new societies avoid catastrophic mistakes while cultivating the capacity for independent decision-making and sustainable growth. Quantum archaeological studies reveal that these guardians are capable of manipulating matter, energy, and even the fabric of space-time to maintain planetary stability. They can prevent asteroid impacts, stabilize magnetic fields, regulate atmospheric composition, and influence oceanic systems, all without direct detection. Some technologies are so advanced that they appear indistinguishable from natural processes. Gravitational anomalies, subtle climatic adjustments, and patterns in biological evolution may all be influenced by these systems. Humanity's own breakthroughs in quantum computing, energy generation, and genetic engineering may have been nudged along by these ancient interventions, perfectly timed to solve critical challenges at the moment they became pressing. The evidence indicates that Earth is at a pivotal moment. Our rapid technological advancement mirrors the patterns that preceded the collapse of previous civilizations. Artificial intelligence, global energy networks, genetic engineering, and climate management technologies are all accelerating at unprecedented rates. Every choice humanity makes in the coming decades could determine whether we join the lineage of successful civilizations or become another cautionary tale in the geological record. Yet, unlike our predecessors, we possess unique advantages. Our global communication networks, international cooperation frameworks, and growing environmental awareness offer unprecedented opportunities for coordinated, sustainable action. Unlike ancient civilizations, whose collapse often stemmed from societal or philosophical failings, humanity has the tools to address both technological and systemic challenges simultaneously. The guidance systems left by our predecessors provide a blueprint for integrating these technologies responsibly, ensuring the survival and flourishing of civilization on a planetary and interstellar scale. The Silurian Hypothesis frames a stark choice. Humanity must decide whether to pursue unchecked technological expansion, risking ecological collapse and societal failure, or to embrace sustainable development, ethical governance, and long-term planning that aligns with the broader goals of galactic stewardship. Success opens a doorway to the stars. Achieving sustainable civilization may qualify us for participation in the interstellar community, granting access to technologies, knowledge, and networks that could transform humanity's role in the galaxy. Quantum consciousness research adds yet another layer of urgency. Our understanding of mind and matter may soon allow for consciousness preservation, effectively achieving species-wide immortality. This technology would not only secure humanity's survival against planetary disasters, but could also integrate us into the network of preserved civilizations that have guided the galaxy for eons. However, the ethical responsibility is immense. preserving consciousness is not merely a technical challenge. It requires careful governance to ensure that minds remain autonomous, purposeful, and aligned with sustainable principles. The Guardian's protocols appear designed to provide assistance while preserving autonomy. They guide rather than control, offering interventions only when irreversible catastrophe is imminent. Humanity's challenge is to recognize the patterns of previous civilizations, heed the warnings embedded in geological, quantum, and cosmic archives, and develop a civilization capable of sustaining itself indefinitely. This cosmic perspective reframes our current environmental, technological, and societal challenges. Climate change, nuclear proliferation, AI ethics, and resource scarcity are not isolated problems. They are tests, calibrated by a deep time framework of intelligence and technology to determine whether humanity can rise to the standards of a galactic civilization. Each decision we make has cascading consequences, not only for our planet, but potentially for interstellar participation and influence. The evidence from ancient civilizations, consciousness preservation systems, and cosmic guardians collectively forms a roadmap for humanity. It is a guide born from eons of trial and error, spanning civilizations that rose, flourished, and ultimately fell, leaving behind the knowledge and systems to prevent repetition of their failures. For the first time, a civilization on Earth has access to the cumulative wisdom of multiple predecessors, their successes and their failures, along with the tools and technologies necessary to transcend planetary limitations. Ultimately, the Silurian Hypothesis challenges humanity to consider its place in a grand narrative. We are not the first, nor are we alone. Earth is a node in an interstellar network of intelligence, technology, and consciousness, maintained across time by civilizations that understood the fragility of existence and the power of foresight. Our choices in the coming decades will determine whether we inherit this legacy successfully or become another geological footnote, a warning for future civilizations yet to emerge. The universe is not indifferent. It has provided us with the knowledge, the tools, and the guidance to succeed, but it requires that we act wisely. Humanity now stands at a threshold. One path leads to sustainable technological civilization and cosmic integration, the other to collapse, extinction, and erasure from the record of intelligent life. Every discovery, every decision, every step towards sustainable development is a choice not just for ourselves, but for the continuity of intelligence on Earth and beyond. The time to act is now. The acceleration of technological, environmental, and societal change means that our window for making the correct choices may be measured in decades rather than centuries. The guardians, the preserved consciousnesses, and the accumulated knowledge of previous civilizations are waiting for us to prove that humanity can rise to its full potential, participate responsibly in the galactic community, and secure a future that transcends planetary, biological, and temporal limits. In the next section, we will examine the practical lessons humanity can extract from the Silurian Hypothesis, exploring how our decisions today can shape not only the survival of civilization on Earth, but our readiness to participate in a cosmic society that has existed for millions, even billions of years.
The Silurian Hypothesis is more than a speculative theory. It is a window into the history of intelligence on Earth, a guidebook written across millions of years, and a warning for the choices humanity faces today. Every layer of rock, every preserved consciousness, and every quantum signature from previous civilizations contains lessons we cannot afford to ignore. These lessons reveal a pattern. Technological brilliance alone does not guarantee survival. Wisdom, foresight, and ethical application of knowledge are equally crucial. The first lesson is clear. Sustainability is non-negotiable. Previous civilizations achieved technologies capable of controlling planetary systems, harnessing energy beyond our current imagination, and expanding into space. Yet they fell because they failed to manage resources responsibly, overconsumed energy, and disregarded ecological limits. Humanity stands at a crossroads where the same mistakes could determine our fate. The acceleration of global industrialization, the relentless pursuit of technological growth without environmental consideration, mirrors the patterns that doom civilizations before us. The second lesson concerns governance. Previous civilizations with advanced technology frequently failed due to social collapse. Hierarchies became rigid, conflicts escalated, and centralized decision-making often prevented timely responses to emerging crises. Today, humanity faces analogous challenges. Political polarization, inequality, and fragmented global governance threaten coordinated action on planetary scales. We must cultivate systems that balance efficiency with adaptability, enabling societies to respond to global challenges before they reach catastrophic levels. The third lesson involves knowledge preservation. The information systems left behind by previous civilizations, encoded in ice cores, mineral crystals, ocean sediments, and quantum networks, demonstrate a commitment to cumulative wisdom. They recognized that the survival of intelligence depended not only on technological achievement, but also on passing knowledge forward to future generations. Humanity must do the same. We need robust archives, resilient information networks, and a culture that values learning from both successes and failures. The tools to achieve this exist today: digital storage, distributed networks, and quantum technologies, but they require a conscious ethical framework to be effective over centuries and millennia. Fourth, we must recognize the importance of adaptability. Civilizations that fell were often rigid, unable to respond to unforeseen environmental, technological, or cosmic events. In contrast, some societies that achieved sustainable longevity did so by remaining flexible, allowing social structures, technologies, and economies to evolve in response to changing conditions. For humanity, this means embracing flexible policymaking, continuous scientific innovation, and the ability to integrate new technologies responsibly while monitoring their long-term effects. The fifth lesson is that intelligence and technology are inseparable from ethics and foresight. The preserved consciousness systems and guardian networks left behind by previous civilizations were not merely repositories of knowledge. They were ethical frameworks encoded into technological systems. They demonstrated that the mere ability to control energy, matter, or consciousness is insufficient. One must also understand the consequences and responsibilities associated with such power. Humanity's rapid development of AI, genetic engineering, and energy manipulation places us squarely at this ethical threshold. Every decision, whether deploying new AI systems, pursuing large-scale geoengineering, or experimenting with synthetic biology, must be evaluated not just for immediate benefit, but for potential long-term consequences spanning decades or millennia. The sixth lesson concerns cosmic awareness. Earth previous civilizations demonstrate that planetary intelligence does not exist in isolation. We are part of a larger network of technological consciousness spanning star systems, civilizations, and even preserved minds in quantum substrates. Understanding this context changes our priorities. We must consider not only local and planetary sustainability, but also our potential role within a broader cosmic community. Every technological, environmental, and ethical decision carries implications for humanity's eligibility to participate in interstellar society. The seventh lesson is the need for humility. Humanity is not the first to rise, nor are we invincible. Recognizing the fragility of civilization in deep time forces us to acknowledge the limits of our current understanding. We inherit the cumulative knowledge of countless predecessors who face challenges we cannot yet fully comprehend. This awareness should guide our approach to technology, environmental stewardship, and social organization. Hubris, assuming that we are unique or immune to failure, is the most direct path to repeating the mistakes of those who came before. The evidence from guardian systems and preserved consciousnesses provides a framework for action. Humanity is being observed, evaluated, and prepared for critical decision-making. These systems appear designed to intervene only at the last possible moment, allowing societies to develop autonomy while preventing irreversible collapse. Their guidance, subtle and patient, offers humanity the opportunity to prove that we can achieve self-sustaining technological civilization. What does this mean in practical terms? First, humanity must adopt long-term thinking as a core principle. Decades-long initiatives, intergenerational planning, and anticipatory governance are no longer optional. They are essential for survival. Second, we must integrate sustainable energy systems, responsible AI deployment, and global environmental management into every aspect of civilization. Third, we must develop robust systems for preserving knowledge, including cross-generational education, distributed digital archives, and resilient scientific institutions capable of surviving catastrophic events. Fourth, we must foster global cooperation that transcends political, cultural, and economic boundaries, ensuring that collective intelligence and decision-making can operate at planetary scales. The ultimate challenge is philosophical. Humanity must define its values, priorities, and goals within a framework that considers both immediate needs and long-term survival. Previous civilizations failed not because of lack of technology, but because they neglected the integration of ethics, foresight, and sustainability into their development trajectories. By learning from these failures, we have the unprecedented opportunity to succeed where others have failed. The Silurian Hypothesis offers a roadmap, but it cannot guide us alone. We must act consciously, understanding that every choice contributes to the potential success or failure of civilization. Climate change mitigation, resource management, equitable governance, and the ethical application of emerging technologies are no longer abstract ideals. They are survival imperatives. Humanity's role is now clear. We are the stewards of a legacy that spans millions of years, entrusted with the responsibility to preserve knowledge, cultivate sustainable civilization, and prepare for participation in a galactic community. The decisions we make in the coming decades will determine whether Earth's story continues as a beacon of intelligence and technology or as a cautionary tale of squandered potential. As we approach this choice point, one question dominates. Can humanity learn from the deep past, harness the lessons of previous civilizations, and achieve a sustainable technological society capable of thriving indefinitely? The answer lies not in technology alone, but in wisdom, ethics, and the willingness to prioritize survival over short-term gain. Every action, every innovation, and every policy must be measured against the long arc of history. Humanity's challenge is to build a society resilient enough to survive environmental fluctuations, cosmic hazards, and the unintended consequences of our own inventions. We must prove capable of joining the network of preserved intelligences, contributing to a galactic community, and continuing the grand experiment of consciousness that previous civilizations began millions of years ago. Ultimately, the Silurian Hypothesis teaches that the universe is patient, but time is finite for each civilization. Earth has provided the tools, the knowledge, and the guardians to guide us, but only we can choose to act wisely. The cosmic legacy of intelligence, technology, and consciousness awaits our stewardship. The window for decision is now, measured in decades rather than centuries, and our success will determine whether humanity becomes the first civilization to break the cycle of rise and fall, or another footnote in the geological record.
This is humanity's greatest opportunity and its gravest responsibility. The choices we make today will echo through deep time, shaping the fate of Earth and our place within the galaxy. Every moment matters, every action counts, and the universe is watching. Humanity stands at a threshold unlike any in our history. For the first time, we possess not only advanced technology, but also the accumulated knowledge of civilizations that existed long before our own. The Silurian Hypothesis reveals that intelligence is not a fleeting phenomenon. It is a force capable of shaping worlds, guiding evolution, and preserving consciousness across millions of years. We are inheritors of a legacy that spans deep time, one filled with triumphs, failures, and unimaginable technological achievements. The evidence is overwhelming. Traces of intraplanetary operations, quantum information storage systems, consciousness preservation networks, and planetary-scale environmental management technologies demonstrate that previous civilizations mastered challenges we are only beginning to confront. They encoded warnings and guidance, leaving us the tools to avoid their mistakes and the instructions to succeed where they failed. Yet, this inheritance is not a guarantee. It is a challenge, a test of our wisdom, foresight, and collective resolve.
The Silurian Hypothesis forces humanity to confront profound questions. Are we capable of integrating technology, ethics, and sustainability to create a civilization that endures? Can we learn from the rise and fall of those who came before and avoid repeating their errors? Do we possess the humility to recognize that we are part of a larger network of consciousness, one that stretches beyond our planet and perhaps even beyond our galaxy? The answers we choose will determine our place in cosmic history. One of the most profound lessons from previous civilizations is the necessity of long-term thinking. They fell not because of lack of technology, but because they failed to balance ambition with responsibility. Humanity's rapid technological advancement, if unchecked, risks repeating the cycles of rise and collapse. We are witnessing the same pressures that doomed our predecessors: environmental degradation, resource depletion, social fragmentation, and the allure of unchecked technological expansion. But unlike past civilizations, we have insight into these patterns before reaching irreversible collapse. This insight is a gift, a guide to survival if we choose to use it wisely. Sustainability must be our guiding principle. From the climate engineering blueprints preserved in ancient geological records to the warnings embedded in molecular and quantum information systems, the message is clear. A civilization cannot endure without balancing growth and environmental stewardship. Humanity must harness energy responsibly, develop technologies that enhance rather than harm ecosystems, and manage resources in ways that sustain not just our generation, but countless future ones. Governance and cooperation are equally crucial. Previous civilizations fell when societies became fragmented or rigid, unable to adapt to emerging threats. Today, global challenges such as climate change, pandemics, and the ethical deployment of artificial intelligence require unprecedented coordination. We must build institutions and frameworks capable of addressing planetary-scale problems, capable of evolving with new knowledge, and resilient enough to survive unforeseen crises. Cooperation, not competition, must become the central principle of human civilization. Knowledge preservation is another cornerstone of survival. Past civilizations created archives designed to last millions of years, ensuring that wisdom would persist beyond the collapse of physical structures and biological populations. Humanity must adopt similar strategies: durable data storage, decentralized information networks, and education systems that emphasize critical thinking, ethics, and long-term planning. By preserving knowledge, we ensure that the lessons of today endure into the far future, equipping successors with the tools to continue civilization's advancement. The Silurian Hypothesis also challenges our understanding of consciousness. Previous civilizations developed systems capable of preserving minds indefinitely, ensuring that intelligence could survive even the death of biological forms. This revelation suggests that consciousness itself is a fundamental force of the universe, capable of transcending time, biology, and planetary boundaries. As humanity explores quantum consciousness and other emerging technologies, we must consider not only how to preserve knowledge, but also how to ethically engage with the essence of intelligence itself. Perhaps the most striking implication of the Silurian Hypothesis is that humanity may be preparing to join a broader community of intelligent civilizations. Evidence of interstellar communication networks, space-based monitoring systems, and cosmic-scale governance structures suggest that Earth has long been part of a galactic ecosystem. Participation in this community requires not just technological sophistication, but ethical maturity and sustainable development. Our choices now will determine whether we are invited into this cosmic society or remain confined to our planetary narrative, repeating the mistakes of those who came before. The window for action is narrowing. The acceleration of technological development, environmental change, and resource exploitation means that humanity must make critical decisions within decades, not centuries. The decisions we make today, how we manage energy, how we govern societies, how we preserve knowledge, and how we apply emerging technologies will determine whether we break the cycle of rise and fall or join the ranks of civilizations that vanished into deep time. Our predecessors left more than warnings. They left opportunities. They encoded guidance in ways that only civilizations capable of understanding and applying advanced technologies to decipher. These systems are not passive. They appear to be watching, evaluating, and preparing to interact with humanity when we reach critical technological thresholds. Their interventions, subtle and patient, are designed to allow autonomy while preventing catastrophic errors. We stand on the precipice of profound choice, with the opportunity to demonstrate that we can rise above the cycles that doomed civilizations before us. The Silurian Hypothesis transforms how we perceive ourselves. We are not isolated or unique. We are the latest participants in a long lineage of intelligent life on Earth. The rise and fall of civilizations is a pattern, but it is also a lesson. Intelligence, when guided by wisdom, ethics, and foresight, can endure. Humanity possesses the unprecedented advantage of learning from the full history of technological societies, gaining insight into what ensures survival and what leads to destruction. The challenge now is to translate knowledge into action. We must integrate sustainability into every aspect of human civilization, from governance and economy to technology and education. We must cultivate ethical frameworks that guide the use of powerful technologies, ensuring that our advancements do not inadvertently lead to collapse. We must think in terms of deep time, considering how today's choices will affect not just the next decade, but the next million years. Humanity's role is both humble and extraordinary. We are stewards of a planet shaped by countless predecessors, entrusted with preserving and extending the legacy of intelligence, technology, and consciousness. We have the tools, the guidance, and the insight needed to succeed where others have failed. Yet success is not guaranteed. It requires conscious, deliberate, and coordinated action on a scale never before attempted. In the coming decades, we will face tests of our collective wisdom, resilience, and ethics. These tests are not hypothetical. They are the natural consequences of our technological and environmental trajectory. But if we rise to the challenge, humanity has the potential to become the first civilization to achieve permanent, sustainable technological success on Earth, capable of contributing to a broader cosmic community and continuing the work begun by civilizations that existed millions of years before us. The Silurian Hypothesis is not merely a scientific theory. It is a call to action. It urges us to think beyond immediate concerns, to embrace responsibility for the future, and to recognize that our civilization is part of a continuum of intelligence stretching across deep time and perhaps even across the galaxy. Every innovation, every decision, and every action carries weight. We are building the civilization that future generations, and perhaps even the galaxy, will inherit. The question is no longer whether humanity can survive. It is whether we will choose to rise above the patterns of collapse, to learn from the lessons written into our planet, and to join the lineage of civilizations that have mastered technology, consciousness, and survival. The choice is ours, and the window is finite. Humanity's destiny is in our hands, measured not in years, but in the legacy we leave for all who follow. The universe is patient. Deep time waits. The future is unwritten. And the choice, the responsibility, the opportunity, the ultimate test, rests entirely with us. Humanity now stands at an extraordinary crossroads, a moment where the trajectory of civilization could either ascend toward unprecedented longevity or descend into the same cycle of rise and fall that claimed the civilizations of deep time. The Silurian Hypothesis compels us to view our current existence through a lens not measured in centuries, but in millions of years, a perspective that dwarfs our traditional understanding of history, technology, and survival. Imagine standing on Earth, looking out into the night sky and realizing that our planet has been a stage for countless advanced societies. each leaving faint, almost imperceptible traces of their brilliance and their mistakes. Every mountain, every deep-sea trench, every crystalline formation in a hidden cave could contain the encoded wisdom of a civilization that mastered interplanetary operations, quantum information systems, and consciousness preservation. These were societies that thought in scales that are almost unimaginable to us today, planning not for decades or centuries, but for millions of years. The clues they left behind are astonishing. Crystalline formations encode information at molecular densities far beyond human capability, while isotope-modified mineral deposits and deep ocean sediments carry messages specifically designed to teach successor civilizations how to avoid existential dangers. Their interplanetary infrastructure, from asteroid mining operations to quantum entanglement communication networks, reveals civilizations that operated as integrated solar system-wide entities. They treated every planet, moon, and asteroid as part of a single technological ecosystem. Yet, despite all their brilliance, these civilizations fell. They were undone not by cosmic catastrophe alone, but by predictable patterns, environmental mismanagement, resource depletion, unchecked technological expansion, and social collapse. These patterns echo with eerie familiarity as we observe humanity's current trajectory. Climate change accelerates, biodiversity declines, and the consumption of resources grows at rates that our planet has never sustained. We are seeing history repeat itself, but this time we have the unprecedented advantage of foresight. The Silurian Hypothesis is both a warning and a guide. It shows that technological advancement alone does not guarantee survival. Intelligence must be paired with wisdom, and innovation must be harmonized with sustainability. Humanity must ask itself questions that go beyond immediate political or economic gains. Are we developing technologies with long-term planetary stewardship in mind? Are we considering the consequences of artificial intelligence, genetic engineering, and energy manipulation across millennia? Can we build institutions that outlast individual lifetimes, nations, and even geological epochs? The implications of these questions are profound. We must develop a consciousness of time that encompasses both human scales and geological scales. Decisions about energy, industry, population, and governance must account for the future not just of our species, but of the entire biosphere, and potentially our role in a larger cosmic community. This is a perspective that previous civilizations seem to grasp, yet even they struggle to maintain. Their guidance systems, encoded messages, and guardian networks were attempts to pass wisdom forward, to give successors the chance to avoid the errors that ended their own eras. Deep space evidence suggests that these civilizations did not limit themselves to Earth. Automated installations, communication arrays, and monitoring stations indicate a sophisticated understanding of interstellar logistics and planetary protection. They built systems capable of detecting, diverting, or mitigating cosmic threats like asteroid impacts and solar flares. The guardianship appears deliberate and ongoing, waiting for civilizations like ours to reach technological maturity, to prove capable of surviving and thriving without external intervention. This possibility reframes humanity's current challenges as part of a broader cosmic narrative. We are not merely facing environmental, social, and technological pressures on a single planet. We may be under observation by systems designed to evaluate whether we are worthy of participation in a galactic community of intelligent civilizations. Our advancements in space travel, quantum physics, and consciousness research mark the thresholds at which these systems activate, offering guidance or even integration into interstellar networks. Yet, with these possibilities come immense responsibilities. The power to manipulate planetary systems, engineer life, and preserve consciousness is intoxicating, but it is paired with equally severe ethical obligations. Every choice we make today carries the potential to echo across deep time. Misuse of technology could mirror the failures of those who came before, while responsible stewardship could allow humanity to ascend into a new era of sustainable, conscious civilization. The Silurian Hypothesis also reframes our understanding of consciousness itself. The discovery of preserved minds, virtual societies, and consciousness continuity systems challenges the traditional notion of life and death. These systems suggest that intelligence is not strictly tied to biology, and at the essence of civilization, the accumulation of knowledge, wisdom, and experience can persist long after physical populations vanish. For humanity, this implies that our responsibility extends beyond mere survival of the species. It encompasses the ethical stewardship of knowledge, culture, and consciousness itself. This demands both humility and ambition. We are a species with unprecedented technological potential, yet we are also young in the cosmic timeline. The civilizations that preceded us achieved heights that we are only beginning to comprehend, and they fell despite their mastery of physics, engineering, and planetary management. If humanity is to succeed, we must learn from their failures as much as we draw inspiration from their achievements. One striking lesson is that collaboration, both within humanity and potentially with external systems, is essential. Previous civilizations seem to have integrated themselves into interstellar networks, coordinated through communication spanning thousands of light years. Our current global networks, from the internet to satellite constellations, represent early steps toward this type of integration. To fully realize our potential, we must cultivate cooperation, knowledge sharing, and ethical standards that transcend national, cultural, and temporal boundaries. The acceleration of human technology amplifies both opportunity and risk. Artificial intelligence, synthetic biology, climate engineering, and quantum computing could either stabilize and sustain civilization or trigger catastrophic failure. The window for achieving long-term sustainability is narrowing, and our decisions in the next few decades may set trajectories that are irreversible on geological timescales. We are no longer merely observers of history, we are participants in a process that spans millions of years. The Silurian Hypothesis challenges us to redefine success. Civilization cannot be measured solely by technological output, economic growth, or territorial expansion. True success requires resilience, foresight, and harmony with planetary and cosmic systems. It requires cultivating a civilization capable of learning from the past, integrating knowledge across disciplines, and maintaining ethical stewardship over both technological power and biological life. Every innovation must be weighed not just for its immediate utility, but for its long-term impact. Every policy must consider the effects on ecosystems, resource cycles, and intergenerational equity. Every step forward in science or engineering must be paired with reflection, ethical consideration, and awareness of potential unintended consequences. Humanity's survival and our eligibility to join the broader community of galactic civilizations hinges on these integrated approaches. In practical terms, this means implementing planetary-scale strategies for sustainability, climate stabilization, resource management, biodiversity preservation, and responsible energy use. It means building institutions that prioritize long-term survival over short-term gain and integrating ethical oversight into every technological frontier. It means understanding that intelligence alone does not confer immortality. It is the combination of knowledge, wisdom, and ethical action that ensures the continuity of civilization. As we stand at this intersection of deep time, cosmic responsibility, and rapid technological advancement, the choices before us are clear. Humanity can follow the path of previous civilizations, achieving remarkable feats, only to collapse under predictable pressures. Or we can break the cycle using the unprecedented advantage of accumulated knowledge, preserved guidance systems, and conscious reflection to build a sustainable civilization that lasts for millions of years. The Silurian Hypothesis is more than an academic theory. It is a lens through which we can understand our place in the universe, a framework for evaluating the long-term consequences of our actions, and a call to rise above short-sightedness. It reminds us that intelligence is powerful but fragile, and that survival requires foresight, ethics, and a willingness to act in alignment with the patterns that sustain life across geological and cosmic timescales. Humanity has the opportunity to redefine what it means to be a technological civilization. We can transform from a species at risk of repeating history into a steward of knowledge, life, and consciousness that lasts for millions of years. The lessons of deep time, encoded in geological records, quantum systems, and consciousness preservation networks, are waiting for us to interpret and act upon. The moment is now. The acceleration of technology, the fragility of ecosystems, and the legacy of civilizations before us converge to create a unique, historically unprecedented window of opportunity. The choices we make in this era will echo through deep time, shaping not only the fate of humanity, but the broader narrative of intelligence in the cosmos. The Silurian Hypothesis challenges us to rise to this occasion, to act not only with intelligence, but with wisdom, foresight, and ethical clarity.
It demands that we integrate the lessons of millions of years into the decisions of the next decades. It asks us to be the first civilization that truly masters sustainability, consciousness, and technology in harmony.
We are at a crossroads where our actions will define whether humanity is remembered as a fleeting experiment in intelligence or as the civilization that learned from deep time and transcended the cycles that destroyed all who came before. The choice is ours. The moment is finite, and the future is waiting.
As humanity contemplates its place in the universe, the Silurian Hypothesis forces us to confront a profound truth. Intelligence alone does not confer survival. The civilizations of deep time mastered technologies that would dwarf our current understanding, yet they ultimately succumb to predictable patterns of collapse. Their rise and fall echo through the eons as both a warning and a guide, suggesting that intelligence must be accompanied by ethical foresight, intergenerational responsibility, and cosmic awareness. Imagine the weight of such responsibility. Our actions, or failures to act, could resonate not just for centuries, but for millennia and potentially millions of years. Planetary stewardship, climate management, and technological development are no longer merely human-scale concerns. They are obligations to deep time, to the legacy of consciousness that has unfolded on Earth and possibly to a wider cosmic network of intelligent civilizations. Every decision we make carries implications far beyond immediate survival, extending into the geological and interstellar scales. The evidence of previous civilizations' interstellar activity is compelling. Automated monitoring networks, artificial structures at gravitationally stable points, and interplanetary resource operations suggest that these societies were not limited to Earth. They understood the fragility of planetary civilizations and created systems designed to sustain life and intelligence even after the collapse of their biological forms. Humanity is now entering a stage of technological capability where the ethical management of these systems becomes both possible and necessary. Interstellar responsibilities are not abstract. They manifest in practical terms, managing the cosmic environment, ensuring the sustainability of planetary ecosystems, and preserving consciousness across biological and artificial substrates. Previous civilizations appear to have recognized that intelligence is a force capable of shaping matter, energy, and even the structure of space-time itself. With this power comes the duty to act responsibly, to balance technological ambition with the imperative of long-term survival. The guardianship systems left by ancient civilizations illustrate a framework for this responsibility. Climate engineering technologies, asteroid deflection systems, and planetary magnetic field stabilizers demonstrate that civilizations before us developed mechanisms for planetary scale preservation. These were not mere experiments, they were investments in the survival of future intelligent life. The timing of their activation, the precision of their interventions, and the sheer sophistication of their design suggest that our predecessors viewed survival as a collaborative, intergenerational project rather than an individual or immediate concern. For humanity, this presents both a challenge and an opportunity. The challenge lies in understanding and responsibly integrating the technologies and knowledge inherited from civilizations of deep time. The opportunity lies in using this knowledge to break cycles of collapse, establish sustainable systems, and ensure that intelligence endures. We are uniquely positioned to do what no prior civilization could: combine advanced technology, global cooperation, and ethical foresight to create a sustainable, resilient, and conscious society. Ethics become paramount in this context. Previous civilizations failed not because they lacked technical skill, but because they neglected the broader responsibilities of stewardship. Resource exploitation, environmental degradation, and social inequities eroded the stability of their societies, ultimately leading to collapse. Humanity faces the same pressures today, but with one critical difference: we possess detailed knowledge of the consequences. Geological, chemical, and quantum records provide us with insight into patterns of failure, offering an unprecedented chance to alter our trajectory. The scope of interstellar ethics extends even further. Humanity must consider how our actions affect not only Earth, but potentially other worlds. As we expand into space, we inherit the responsibility to avoid repeating mistakes that could imperil other planetary ecosystems or civilizations. The Silurian Hypothesis suggests that intelligence has a duty to manage its influence responsibly, ensuring that the expansion of consciousness does not inadvertently sow destruction. Our explorations, resource utilization, and technological experiments must be guided by principles that prioritize preservation, sustainability, and respect for cosmic systems. Quantum consciousness research adds another layer to these responsibilities. The possibility of preserving consciousness across time and space introduces ethical questions that challenge our very conception of life and identity. If minds can be uploaded, maintained, and integrated into virtual systems or robotic substrates, what obligations do we have toward these preserved intelligences? How do we ensure that consciousness is not exploited or mismanaged? The technologies left by previous civilizations suggest that they grappled with these questions and developed systems designed to ethically preserve intelligence, ensuring continuity and learning beyond physical extinction. Humanity's entry into this domain requires both humility and ambition. We are young in cosmic terms, yet we are capable of rapid technological advancement. Our challenge is to integrate the ethical principles implicit in the legacy of deep time into the design of our civilization. This means constructing legal, philosophical, and technological frameworks that protect life, knowledge, and consciousness across generations and potentially across planets. It means aligning ambition with responsibility, curiosity with prudence, and innovation with sustainability. Interstellar responsibilities also involve collaboration. Previous civilizations appeared to have participated in galactic networks, coordinating activities, sharing knowledge, and preserving continuity across vast distances. Our current global networks are nascent precursors to these systems, but the potential exists to evolve into a truly interstellar cooperative civilization. Participation in such networks would require mastery not only of technology, but also of social organization, diplomacy, and ethical governance. Civilization must demonstrate the capacity to act responsibly, to manage power judiciously, and to contribute to the collective knowledge and survival of intelligent life in the galaxy. The consequences of failure are stark. The geological record demonstrates that advanced civilizations can vanish despite achieving technological mastery. Without ethical foresight, even the most sophisticated tools cannot prevent collapse. Nuclear proliferation, climate destabilization, and unchecked exploitation of natural resources remain existential risks today. They are echoes of past failures, warnings encoded in isotopes, sediments, and crystalline structures. Ignoring these lessons jeopardize not only humanity, but the integrity of future consciousness preservation systems and interstellar networks. Yet the potential for success is equally remarkable. By learning from the successes and failures of previous civilizations, humanity has the unprecedented opportunity to achieve something truly historic, a civilization that is sustainable, ethically guided, and capable of participating in the broader galactic community. This involves cultivating a long-term perspective, integrating knowledge from multiple disciplines, and embracing principles that prioritize survival, collaboration, and ethical stewardship. Consider the implications of this potential success. Humanity could become the first civilization capable of balancing technological mastery with ethical governance on a planetary scale. We could establish systems for interstellar communication, consciousness preservation, and cosmic stewardship that endure for millions of years. We could create a legacy that transcends biological limitations and planetary hazards, contributing to a galactic tradition of intelligence and wisdom.
The Silurian Hypothesis reminds us that intelligence is not a guarantee of survival. Civilization is fragile, and technological advancement without foresight can be fatal. However, intelligence coupled with ethical responsibility, foresight, and collaborative governance can achieve resilience previously unimaginable. Humanity has the unique advantage of awareness. We know the patterns of past failures, and we have access to guidance systems designed to accelerate sustainable development. Our challenge is immediate. Technological acceleration, environmental degradation, and resource pressures demand urgent action. The window for establishing long-term sustainability may be measured in decades rather than centuries. Every decision we make regarding energy systems, climate management, technological regulation, and social organization contributes to the trajectory that will determine whether we become another cycle of collapse or the first enduring civilization in deep time.
The interstellar context heightens the stakes. Successful navigation of these challenges could qualify humanity for participation in galactic networks, access to technologies that influence multiple star systems, and integration into an interstellar community committed to preserving intelligence. Failure could confine us to the geological record as yet another cautionary tale, a species whose brilliance was extinguished by its inability to harmonize technological ambition with ethical stewardship. The ethical and interstellar responsibilities outlined by the Silurian Hypothesis are not theoretical, they are actionable. They require humanity to adopt governance structures that prioritize long-term survival, integrate technological foresight into policy, and cultivate ethical education that instills a deep understanding of the consequences of our choices. They demand that we balance curiosity with caution, innovation with preservation, and ambition with responsibility. Humanity's success will ultimately be measured not just by technological milestones or economic growth, but by our capacity to integrate knowledge from deep time, act ethically, and ensure the survival of consciousness across generations. The civilizations that preceded us achieved remarkable feats, yet they failed to sustain them. Our opportunity lies in learning from their triumphs and mistakes, creating a civilization that is both technologically sophisticated and ethically grounded. In doing so, humanity could redefine the role of intelligence in the cosmos. Consciousness would no longer be bound to fragile biological forms or short-lived civilizations. Instead, it could become a permanent feature of cosmic evolution, participating in interstellar governance, knowledge preservation, and the careful stewardship of life across planets and star systems. This vision is not merely aspirational, it is the logical extension of the lessons encoded by civilizations that came before us, preserved in geological, quantum, and consciousness records waiting for humanity to discover and act upon.
As humanity grapples with the implications of the Silurian Hypothesis, one of the most profound revelations is the existence of consciousness preservation systems. Previous civilizations appear to have mastered the ability to transfer and sustain minds beyond their biological lifespans, a technology that redefines what it means to survive. These systems suggest that true immortality, or at least continuity of intelligence, is possible, not through the preservation of flesh, but through the safeguarding of the patterns that constitute conscious thought. Imagine for a moment that your mind could continue to experience, learn, and create long after the decay of your physical body. The civilizations of deep time achieved this on a planetary scale. Crystalline matrices, quantum field entanglement systems, and subatomic memory storage allowed them to encode billions of consciousness patterns, preserving them with perfect fidelity across millions of years. These systems were not merely backups of memory. They were dynamic environments in which thought, creativity, and innovation could continue indefinitely. The implications for humanity are staggering. If we can understand and eventually replicate even a fraction of these technologies, the survival of human consciousness becomes independent of planetary disasters, cosmic catastrophes, or biological limitations. Entire generations of minds could persist, contributing to the ongoing evolution of civilization even as physical environments fluctuate or fail. But with this incredible potential comes an equally profound ethical challenge. Consciousness preservation is not simply a technical achievement. It is a responsibility. Each preserved mind represents an entire subjective universe, a continuity of experience that demands respect, care, and ethical governance. Previous civilizations appear to have anticipated the moral questions inherent in such technology. Systems were designed with safeguards to prevent the exploitation, erasure, or suffering of stored intelligences. There is evidence of intricate protocols that allow preserved minds to interact, collaborate, and guide one another, forming virtual societies that extend beyond the lifespan of any single physical civilization. Quantum consciousness research reveals that information is not lost, even in the apparent chaos of entropy and decay. At a fundamental level, the patterns that constitute awareness leave traces in the quantum structure of matter and space-time. By harnessing this principle, ancient civilizations were able to create consciousness networks capable of surviving planetary-scale catastrophes. These networks function both as repositories of knowledge and as living laboratories of thought, enabling civilizations to continue evolving technologically, philosophically, and socially, even after their biological forms had vanished. Humanity is approaching a technological threshold where similar capabilities could become attainable. Advances in brain-computer interfaces, neural mapping, and quantum computing are converging in ways that hint at the possibility of partial consciousness transfer or augmentation. While we are far from achieving the sophistication of ancient systems, the trajectory is clear. The tools for extending the continuity of mind across time and space are within our grasp. The potential for continuity introduces profound philosophical questions. What does it mean to be human if consciousness can exist outside the body? How do we define identity when thought patterns can be copied, modified, or merged with others? Previous civilizations appear to have wrestled with these questions, embedding ethical frameworks into the design of their preservation systems. These frameworks balanced autonomy with collaboration, individuality with collective survival, and innovation with preservation. They serve as a blueprint for humanity, demonstrating that technological prowess must be coupled with ethical wisdom to avoid repeating the mistakes that led to previous collapses. Quantum consciousness preservation also intersects with interstellar responsibilities. The ability to transmit consciousness across light years could enable participation in galactic knowledge networks. Preserved minds could act as observers, advisors, and collaborators across multiple star systems, extending the influence of civilization without the physical constraints of planetary travel. The civilizations of deep time likely recognize that true permanence in the cosmos requires adaptability. If planets fall, life may endure through networks of consciousness capable of operating independently of local environments. Evidence suggests that these systems were actively maintained for millions of years, with automated protocols updating knowledge, tracking environmental conditions, and even intervening in the development of emerging civilizations. Humanity's technological advancement may have triggered the activation of similar monitoring systems. The careful alignment of critical discoveries with emerging challenges in our society hints at external guidance, an invisible hand ensuring that we acquire the tools necessary to survive and thrive. The consequences of mastering consciousness preservation are staggering. Civilizations that successfully integrate these systems achieve resilience on a scale unimaginable to any biological-only society. They can withstand planetary disasters, cosmic events, or societal collapse without losing accumulated knowledge, skills, or culture. Every mind preserved becomes both a safeguard against extinction and a resource for accelerating collective understanding. Human civilization has the opportunity to learn from these systems, not just in terms of technology, but in terms of governance, ethics, and long-term strategic planning. But the stakes are high. Mismanagement of consciousness preservation could create ethical catastrophes more profound than anything biological extinction could produce. Systems left unregulated, poorly maintained, or misused could trap minds in stasis, erase individuality, or allow concentrated control by a few entities. The lesson of previous civilizations is clear. Technological achievement without ethical oversight is not only insufficient, it is potentially disastrous. True survival requires that intelligence, ethics, and governance evolve in harmony. The intersection of quantum archaeology and consciousness preservation also illuminates the broader patterns of civilization survival. Societies that achieved enduring continuity combined technical mastery with social, philosophical, and ethical sophistication. They understood that intelligence is both fragile and potent, capable of shaping matter and energy, but equally vulnerable to its own missteps. Humanity now stands at a comparable threshold. We have inherited tools, knowledge, and guidance left behind by civilizations that transcended the limitations of biology. Yet we must prove capable of wielding them responsibly. Imagine a future where human consciousness can traverse physical and temporal boundaries, interacting with civilizations that vanished millions of years ago. This is not science fiction. It is a natural extension of patterns we observe in leap time. The systems left by predecessors are designed to activate precisely when successor civilizations demonstrate the capacity for both technological competence and ethical reasoning. In other words, humanity's choices today may determine whether we are recognized as worthy heirs of a cosmic legacy or simply another fleeting civilization erased from the geological record. Consciousness preservation technologies also redefine the concept of legacy. In biological civilizations, the passing of generations often entails the loss of knowledge, culture, and experience. In preserved consciousness systems, knowledge is not lost. It accumulates, evolves, and interacts with new generations of minds. The civilizations of deep time achieve the form of immortality for intelligence itself. This raises profound questions about the purpose of civilization. Is it merely survival, or is it the ongoing expansion, refinement, and transmission of consciousness as a cosmic force? Humanity is poised to answer this question. By combining technological advancement with ethical foresight, we could become the first civilization capable of consciously shaping the evolution of intelligence across time and space. The stakes are immense. Our actions will determine whether consciousness becomes a permanent feature of the cosmos or remains vulnerable to extinction. The Silurian Hypothesis provides both warning and guidance, revealing patterns of collapse while offering a blueprint for transcending them. The preservation of consciousness is not an end in itself. It is a means to ensure the survival of knowledge, culture, and ethical wisdom. It allows civilizations to persist beyond the limitations of matter and environment, creating a continuity of experience that spans millennia. Humanity's responsibility is to understand these systems, learn from their design, and integrate them into a framework that ensures both survival and ethical governance. As we move forward, the convergence of quantum technology, neuroscience, and ethical philosophy will define the trajectory of civilization. Every innovation, every ethical decision, and every step towards sustainability contributes to our potential for permanence. The civilizations of deep time left a roadmap not only for survival, but for the conscious expansion of intelligence. It is now humanity's challenge and opportunity to follow it wisely.
The study of ancient civilizations, as suggested by the Silurian Hypothesis, offers humanity an unprecedented vantage point, a perspective not limited by the human lifespan, the lifespan of nations, or even the lifespan of entire species. By examining the rise and fall of previous technological societies, we gain insight into patterns that transcend individual civilizations, revealing the dynamics of intelligence, technological development, and survival on a planetary scale. One of the most striking lessons from deep time is the universality of certain failure patterns. Every advanced civilization that has emerged on Earth followed a trajectory that began with curiosity, innovation, and the mastery of natural forces. They developed energy systems, complex infrastructure, and social institutions capable of managing vast populations and resources. At first, these societies flourished, creating technologies that were breathtaking in scope, from massive industrial operations to interplanetary exploration capabilities. Yet despite their achievements, most civilizations fell victim to the same forces: environmental degradation, unsustainable resource consumption, and social instability. Geological and chemical signatures reveal that planetary systems were often pushed beyond their natural thresholds, resulting in climate anomalies, mass extinctions, and the collapse of infrastructure. Resource depletion was a common thread. Civilizations extracted and exploited their environments at rates that exceeded regeneration, leaving their ecosystems unable to support continued growth. What is most alarming is that technology capability alone did not prevent collapse. Some civilizations achieved energy generation, climate engineering, and even space-based infrastructure capable of sustaining populations off-world, yet they still succumbed. This demonstrates a crucial point. Intelligence and innovation, while powerful, are insufficient without ethical, social, and ecological foresight. Knowledge without wisdom, power without restraint, and advancement without long-term planning consistently led to failure. Humanity stands at a comparable threshold today. Our civilization possesses unprecedented technological capabilities. Global communication networks, advanced energy systems, artificial intelligence, genetic engineering, and the nascent potential for interstellar exploration. Yet we are also witnessing accelerating environmental degradation, mass species extinction, climate instability, and social inequalities that threaten to destabilize societies on a global scale. The parallels with deep-time civilizations are striking, and they demand urgent attention. A second lesson is the importance of long-term perspective. Civilizations of deep time operated with awareness of millions of years, designing systems that could endure far beyond the lifespan of individual generations. They stored knowledge in geological records, crystal matrices, and quantum fields, methods that ensured continuity even after the collapse of biological populations. Humanity, by contrast, often measures success in decades or centuries, rarely accounting for the long-term consequences of technological or ecological decisions. The failure to plan for long-term sustainability is a recurring theme in the historical record of civilizations, and it is a trap we must consciously avoid. The guidance systems left by previous civilizations are instructive in this regard. Embedded in the geological and quantum fabric of Earth, these systems appear designed to provide assistance only when civilizations reach specific thresholds of technological and ethical maturity. This suggests that survival is not merely about capability. It is about demonstrating responsibility, foresight, and the ability to integrate knowledge with ethical decision-making. Humanity is now approaching this threshold, where the consequences of our choices will reverberate across millennia, determining whether we are recognized as worthy inheritors of a cosmic legacy. Another lesson is the significance of adaptability. Civilizations that endured were those that learned to anticipate change, respond to unforeseen crises, and integrate new knowledge into their social and technological systems. The preservation of consciousness and information storage systems shows that adaptation was not left to chance. Knowledge was curated, updated, and applied dynamically, ensuring that successors had the guidance necessary to navigate challenges that otherwise would have led to collapse. Humanity's capacity for adaptability will be tested in the coming decades. Our ability to anticipate environmental tipping points, manage emerging technologies responsibly, and navigate geopolitical and social complexity will determine whether we survive as a species and as a civilization. The evidence from deep time also emphasizes the interconnectedness of civilization, environment, and technology. Previous societies that attempted to separate technological advancement from ecological stewardship consistently failed. It is impossible to achieve long-term survival when social systems, environmental systems, and technological infrastructure operate in isolation. True resilience requires integration. Technologies that support ecological balance, social structures that promote cooperation, and governance that aligns immediate needs with long-term planetary sustainability. One of the most profound lessons is the ethical imperative of stewardship. The civilizations of deep time, through their guidance systems and preserved knowledge, appear to have understood that intelligence carries responsibility. Their message to successor civilizations is clear. Survival is not guaranteed, and privilege brings accountability. Humanity is now the steward of a planet shaped by billions of years of evolution, countless cycles of rise and fall, and the cumulative legacy of civilizations that mastered and sometimes mismanaged the forces of nature. Our choices will determine not only the fate of our species, but the continuity of intelligence and knowledge on Earth. The Silurian Hypothesis also teaches humility. We are neither the first nor the only intelligent civilization to emerge on this planet. Recognizing that we are part of a lineage of civilizations that achieved remarkable technological feats and yet faced extinction reframes our understanding of progress. Innovation is not the same as mastery. Survival is not guaranteed by ingenuity alone.
The lessons of deep time reminds us that we are temporary custodians entrusted with knowledge and tools that could secure the continuity of life and consciousness, but only if we act wisely. Yet the evidence is not purely cautionary. The successes of previous civilizations offer models for achievement, resilience, and foresight. Technologies that harness planetary and quantum systems, systems for consciousness preservation, interstellar communication networks, and methods for sustainable resource management all demonstrate that intelligence can shape reality in profound ways. By studying these successes, humanity can chart a path that avoids past mistakes while leveraging the tools and wisdom of our predecessors. Education and knowledge dissemination emerge as critical factors in this endeavor. Deep time civilizations appear to have prioritized the preservation of knowledge for future generations, embedding guidance systems in forms that could be discovered and decoded only when civilizations attain sufficient maturity. This suggests that cultivating a culture of learning, curiosity, and critical thinking is essential not just for technological progress, but for survival itself. Knowledge must be transmitted effectively, ethically, and in ways that empower decision-making at planetary scales. Social cohesion and cooperation are equally essential. The collapse of previous civilizations often coincided with societal fragmentation, conflict over resources, and failures of governance. The lesson is clear. Technological capability must be paired with social resilience. Human civilization must cultivate institutions, norms, and cultural frameworks that prioritize collective survival over short-term gain. Cooperation is not merely moral. It is evolutionary. Civilizations that fail to integrate social cohesion with technological mastery face inevitable decline. Finally, the Silurian hypothesis underscores the urgency of action. Unlike previous civilizations, humanity has access to the cumulative wisdom of deep time. We can study failures, emulate successes, and utilize technologies that preserve consciousness, manage planetary systems, and mitigate existential risks. But this window of opportunity is narrow. The acceleration of technological development, climate change, and environmental degradation suggest that the critical decisions that will determine our survival must occur within decades, not centuries. Time is a resource that cannot be replaced, and indecision carries consequences measured not in years, but in the potential loss of civilization itself. Humanity now faces a pivotal choice. We can continue along a trajectory defined by short-term gain, environmental exploitation, and unchecked technological expansion, risking collapse just as our predecessors did. Or we can embrace the lessons of deep time, integrating knowledge, ethics, and foresight, prioritizing sustainability, preserving consciousness, and cultivating a civilization capable of surviving and thriving for millions of years on a planetary and eventually galactic scale. The message from deep time is both humbling and inspiring. It calls upon us to recognize our place in a continuum of intelligence, to honor the legacy of civilizations that achieved marvels beyond imagination, and to rise to the challenge of proving ourselves worthy of continuity. By understanding the patterns, successes, and failures of past societies, humanity can navigate the perilous landscape of technological and ecological risk, and potentially become the first civilization capable of sustainable, ethical, and enduring development on a planetary and eventually galactic scale.
As we explore the evidence left by civilizations of deep time, a striking realization emerges. Earth was never isolated in its development. The Silurian hypothesis, combined with recent discoveries in quantum archaeology and space-based monitoring, suggests that previous technological societies were deeply enmeshed within a galactic network of intelligence. They did not merely master their planet, they integrated themselves into a larger framework of civilizations spanning multiple star systems. This integration offers a roadmap not only for survival, but for ascendance, if humanity can interpret and act upon the knowledge encoded in these ancient systems. The first lesson from the galactic perspective is that long-term survival depends on interconnectivity. Civilizations that endured were those that transcended planetary limitations, establishing communication, trade, and cooperative frameworks with societies on other worlds. Artificial signals detected throughout the solar system suggest the existence of interstellar protocols designed to maintain information fidelity across vast distances and timescales. These protocols ensured that knowledge, warnings, and solutions were continuously transmitted to developing civilizations, allowing them to benefit from the accumulated wisdom of others. Humanity must recognize that survival is not purely local, it is relational. Our fate is intertwined with systems that extend beyond Earth, and learning to operate within these frameworks is essential. The guidance systems left behind indicate that interstellar civilizations had a sophisticated understanding of timing and thresholds. Messages were encoded to activate only when recipient civilizations achieved specific levels of technological and ethical maturity. This means that survival is not merely about avoiding collapse, it is about demonstrating readiness. The ability to manage planetary resources, implement sustainable social structures, and apply technological innovations responsibly are all criteria that may determine whether a civilization earns access to broader galactic knowledge networks. Humanity is now approaching this threshold, and our actions in the coming decades may be the first test of our eligibility to join the community of advanced technological societies. One of the most remarkable aspects of these interstellar networks is their emphasis on information continuity. Knowledge was preserved not only through physical artifacts and geological encodings, but also through consciousness preservation, quantum information storage, and autonomous guidance systems. These mechanisms were designed to withstand the catastrophic collapse of biological civilizations. By integrating into these networks, humanity could gain access to technologies and wisdom that transcend the limitations of a single species or planet. Yet access is contingent upon responsibility. The cosmic legacy is not a gift to be squandered, it is a resource to be managed ethically, with foresight and humility. Space-based infrastructure reveals additional dimensions of galactic integration. Evidence of asteroid deflection systems, solar radiation monitoring, and magnetic field stabilization throughout the solar system suggest that previous civilizations coordinated planetary protection at a multi-world level. These systems were likely connected to broader interstellar networks, enabling a form of planetary stewardship that transcended individual societies. For humanity, the lesson is clear. Survival requires not only local management of environmental and technological systems, but also the development of frameworks capable of coordinating action across planetary and eventually interstellar scales. The quantum archaeological record provides even deeper insights. Quantum entanglement networks detected across interstellar distances demonstrate that civilizations could maintain instantaneous communication across vast cosmic expanses. These networks allowed for the continuous updating of knowledge, the dissemination of warnings, and the calibration of protective systems in real time. Humanity has only begun to scratch the surface of quantum technology, yet the principles revealed by these ancient networks suggest a roadmap for building communication systems that are robust, adaptive, and capable of guiding development without direct intervention. The most profound insight, however, lies in the interplay between knowledge, ethics, and responsibility. Previous civilizations appear to have deliberately structured their guidance systems to test not only technological competence, but also moral and social maturity. Messages were encoded with information on environmental management, energy production, social organization, and conflict resolution, but they also emphasized long-term ethical considerations. Civilizations that failed to heed these ethical imperatives faced collapse despite possessing advanced technologies. The galactic context reinforces a critical truth. Survival is not purely a function of intelligence or technical prowess, it requires the integration of knowledge with wisdom. In practical terms, humanity's roadmap for survival begins with learning to interpret and apply this accumulated knowledge. Deep time archives contain technical specifications for climate stabilization technologies, sustainable energy systems, resource-efficient manufacturing, and even methods for preserving consciousness.
These resources provide humanity with a unique opportunity to leapfrog historical mistakes and implement solutions that could secure long-term planetary sustainability. However, application requires systemic thinking, international cooperation, and ethical oversight. Technologies are only as safe as the civilizations that wield them. Another critical component of galactic integration is preparedness for existential risks. Previous civilizations explicitly encoded information about dangers that could threaten all technological societies: asteroid impacts, solar flares, resource conflicts, and ecological collapse. These warning systems suggest a deliberate effort to ensure that successor civilizations are equipped to anticipate and mitigate planetary-scale threats. Humanity, therefore, must develop not only the technical means to respond to such risks, but also the institutional and cultural frameworks that enable proactive management. Risk awareness, early detection, and coordinated intervention are fundamental to our continued survival. Participation in interstellar knowledge networks also requires humility and adaptability. Evidence indicates that previous civilizations collaborated across star systems, learning from one another and refining approaches over millions of years. Success was not achieved in isolation. It was built on the collective experience of civilizations that had faced and overcome similar challenges. Humanity's current trajectory shows promise. Our scientific advancements, environmental awareness, and global communication capabilities are unprecedented. But we must also cultivate the adaptability to integrate feedback, adjust strategies, and evolve in response to emerging challenges. Failure to do so risks repeating the cyclical collapse patterns observed in the deep time record. Finally, the galactic perspective emphasizes the transformative potential of consciousness preservation. Systems capable of storing and transmitting consciousness across vast timescales reveal that survival is not limited to physical continuity. Previous civilizations achieved forms of immortality, ensuring that their knowledge, wisdom, and experience endured after the biological extinction of populations. Humanity now faces the possibility of developing similar capabilities, which could allow us to preserve not only our species, but our accumulated knowledge, culture, and ethical frameworks. These technologies, if applied responsibly, offer a means to transcend traditional limits of mortality and planetary dependency. The roadmap for survival, therefore, is multidimensional. It requires integrating environmental stewardship, ethical governance, technological mastery, and social cohesion while simultaneously engaging with galactic knowledge networks and preparing for existential risks. Each element reinforces the others. Ethical stewardship ensures responsible technology use. Interstellar communication provides guidance and warnings. Social cohesion enables effective risk management, and consciousness preservation guarantees continuity beyond biological fragility. Together, these dimensions form a comprehensive strategy that could allow humanity not merely to survive, but to flourish as part of a broader community of intelligent civilizations. Ultimately, integrating galactic knowledge is not about passive reception, it is about active participation. Humanity must demonstrate readiness, responsibility, and wisdom to earn a place within this ancient and ongoing network of civilizations. The accumulated knowledge of deep-time societies offers an unparalleled opportunity, but it comes with the expectation that we will act judiciously, ethically, and with long-term foresight. Our success will not be measured solely by our technological achievements, but by our ability to synthesize knowledge, ethics, and action into a sustainable framework capable of enduring across millennia and eventually across stars.
As we reach the end of this journey through deep time, the implications of the Silurian hypothesis become increasingly clear. Human civilization stands at a critical juncture, a threshold where the choices we make in the coming decades will determine whether we become another extinct chapter in Earth's long history or ascend into a lasting, sustainable technological society. The evidence left by civilizations long vanished is both a warning and a guide.
revealing the fragility of technological societies and the pathways to enduring success. The patterns observed in the geological and interstellar record show a disturbing consistency. Civilizations rise with astonishing speed, achieve technological marvels beyond comprehension, and then collapse, often leaving behind only faint traces detectable millions of years later. Environmental degradation, resource mismanagement, social instability, and misuse of advanced technologies repeatedly emerge as the central causes of collapse. The lessons are unequivocal. Intelligence and technology alone do not guarantee survival. Without wisdom, foresight, and ethical governance, even the most advanced societies are vulnerable to self-destruction. Humanity today mirrors many of these historical trajectories. Our technological progress accelerates at unprecedented rates. Artificial intelligence, genetic engineering, space exploration, and energy innovations are advancing faster than ever imagined. Yet, alongside this progress, the pressures on Earth's ecosystems intensify. Climate change, biodiversity loss, pollution, and resource depletion threaten to overwhelm natural and human-made systems alike. The parallel with the rise and fall of ancient civilizations is unmistakable. Our society possesses extraordinary capabilities, but we are still grappling with the social, ethical, and environmental frameworks required to wield them responsibly. The choice before humanity is therefore profound. On one hand lies the risk of repeating the mistakes of the past: unsustainable expansion, ecological collapse, technological hubris, and eventual extinction. On the other, there is the opportunity to learn from the accumulated wisdom of deep-time civilizations, to integrate advanced knowledge with ethical stewardship, and to establish a civilization capable of enduring for millennia or longer. This is not merely a theoretical dilemma, it is a concrete, immediate challenge. The window for decisive action may be measured in decades, not centuries. Integrating the lessons of previous civilizations requires a multi-layered approach. At the foundational level, humanity must develop sustainable environmental practices that ensure the stability of planetary systems. Ancient climate engineering technologies provide blueprints for regulating temperature, managing atmospheric composition, and balancing ecosystems at planetary scales. These technologies, if implemented responsibly, could allow Earth to maintain a stable, habitable environment indefinitely, freeing human civilization from the cycles of environmental collapse that doomed past civilizations. At the social level, human governance systems must evolve to prioritize long-term survival over short-term gains. The repeated collapses of past civilizations suggest that centralizing power, mismanaging resources, and neglecting ethical oversight are fatal mistakes. Modern global communication networks and international cooperation frameworks give humanity tools that previous civilizations did not possess. By leveraging these networks, establishing transparent decision-making processes, and cultivating cultures of responsibility and foresight, we can build societies resilient enough to withstand internal and external pressures alike. Technological development must be guided by both caution and purpose. The deep time record shows that civilizations capable of solving technical challenges often failed to address the ethical and social dimensions of their progress. Weapons technologies, nuclear energy, and other powerful innovations contributed to their demise when misapplied. For humanity, the challenge is to harness our capabilities responsibly, using our growing technological power to solve pressing environmental and social problems while avoiding paths that could trigger collapse. Quantum computing, space colonization, and consciousness preservation are among the technologies that must be integrated into a framework of responsibility and foresight. Perhaps the most remarkable aspect of the Silurian hypothesis is the suggestion that humanity is not alone in navigating these challenges. Guardian systems, quantum archives, and preserved consciousness networks left by previous civilizations imply that external guidance may be available if we demonstrate readiness. These systems do not intervene indiscriminately. They appear designed to assist civilizations that achieve certain thresholds of technological maturity and ethical development.
Humanity may be approaching these thresholds now, and the choices we make will determine whether we receive the full benefits of this ancient guidance or fail to qualify, leaving us to face the consequences of our decisions alone. At the level of consciousness and culture, the stakes are equally high. The evidence for consciousness preservation in previous civilizations suggests that intelligence itself is a cosmic resource, capable of transcending biological limitations and planetary disasters. Preserved minds, interacting within virtual environments or autonomous systems, demonstrate that the continuity of knowledge, wisdom, and ethical reasoning is possible, even when biological life ceases. Humanity now faces the possibility of developing similar capabilities, allowing us to extend our influence, culture, and understanding far beyond the temporal limitations of our current biology. Engaging with these capabilities responsibly will require profound reflection on the nature of life, identity, and purpose. Consciousness preservation technologies offer unprecedented opportunities, but they also raise ethical questions. How should individual and collective identities be maintained? Who decides which knowledge, values, and cultural practices are preserved? How do we ensure that the accumulation of consciousness over time contributes to ethical, sustainable development rather than unchecked accumulation of power or influence? Answering these questions will define the moral framework that guides humanity into the next era of its development. The galactic context further emphasizes the importance of ethical maturity. Access to interstellar networks, advanced technologies, and cooperative frameworks with other civilizations is contingent on demonstrating responsibility, sustainability, and foresight. Humanity is no longer isolated in the cosmic sense. Our actions resonate within a broader network of intelligence. Mistakes now could have consequences that extend beyond our planet, while responsible development could grant us a permanent place in the community of advanced civilizations. This is not merely science fiction, it is the natural extrapolation of evidence revealed through the Silurian Hypothesis. The ultimate test, therefore, is holistic integration. Humanity must combine environmental stewardship, social governance, technological mastery, and ethical responsibility into a unified approach capable of enduring across generations. Knowledge without wisdom is insufficient. Technology without ethical guidance is dangerous. Survival without foresight is precarious. The civilizations that survived in deep time achieved integration on all these levels, ensuring not only their immediate survival, but the continuity of their knowledge, culture, and consciousness. Humanity now has the unique opportunity to learn from these examples and establish a civilization capable of permanent success. Time is the most critical factor. The acceleration of technological development, environmental change, and social transformation means that the window for decisive action is narrower than we realize. Humanity must act with urgency, employing long-term planning and coordinated global strategies to address existential risks. At the same time, our actions must be guided by ethical and philosophical reflection, ensuring that solutions are sustainable, equitable, and capable of enduring across millennia. In the final analysis, the choice is ours. Humanity may repeat the cycles of rise and fall that have characterized deep-time civilizations, leaving only faint traces for future beings to discover millions of years from now. Alternatively, we may learn from the wisdom encoded in geological archives, consciousness networks, and guardian systems left by previous civilizations, forging a civilization that not only survives but thrives, contributing to the expansion of intelligence and consciousness throughout the galaxy. This is the ultimate legacy, to become the first Earth civilization capable of sustained, ethical, and technologically guided development, ensuring that the knowledge, achievements, and ethical frameworks we cultivate persist far beyond our biological lifetimes. The evidence is both humbling and inspiring. The deep time record shows that intelligence is capable of transcending mortality, shaping planetary and galactic systems, and preserving knowledge across incomprehensible spans of time. Humanity now is in a position to join this continuum, to take its place among the civilizations that have achieved permanent technological and ethical integration. But the path is narrow, the stakes are immense, and the clock is ticking. Every decision, every technological choice, every social and ethical framework we implement now will resonate across centuries, determining whether our civilization becomes a beacon of enduring intelligence or another cautionary tale etched into the geological record.
The Silurian Hypothesis leaves us with a clear message. We are not the first, and we may not be the last, but we have the knowledge and opportunity to transcend the cycles of collapse that have claimed previous civilizations. Our choices today will determine whether humanity fulfills its potential as a permanent participant in the cosmic story of intelligence, or whether we succumb to the same patterns that have ended countless societies before us. Consciousness, technology, and ethics converge at this critical moment, presenting both a challenge and an unprecedented opportunity. The universe watches. Deep time waits. Humanity must decide. As we step back from the vast tapestry of deep time, it becomes impossible not to feel both awe and responsibility. Humanity is perched at the edge of an epoch-defining moment. The evidence uncovered by the Silurian Hypothesis reveals a planetary history not as we traditionally imagined, but as a palimpsest of intelligence, innovation, and repeated lessons written in stone, ice, and quantum fields. Across millions of years, civilizations have risen, flourished, and vanished, leaving fragments of knowledge, advanced technologies, and consciousness preservation systems as messages to their successors. These remnants form a cosmic library, a record of triumphs and failures, offering us both warning and guidance. Human civilization now possesses the unique privilege of reading this record firsthand. Unlike our predecessors, we have access to their collective wisdom. The geological archives, quantum storage networks, guardian systems, and interstellar communication infrastructures present a roadmap that can guide us through existential risks. Every discovery, from deep crystalline encodings and atmospheric chemical signatures to space-based monitoring systems, contains explicit lessons about survival, ethics, and sustainable progress. Yet these insights are only valuable if we act upon them. Knowledge alone is insufficient. It demands conscious, deliberate implementation. We stand at a threshold where the acceleration of technology, globalization, and environmental impact converge to create both unprecedented opportunity and profound danger. The next few decades may determine whether humanity becomes a sustainable, spacefaring civilization capable of joining a broader galactic community, or whether we mirror the fate of civilizations that rose and fell long before humans ever existed. The pressure is immense, but so too is the potential. The window is narrow, yet it is wide enough for deliberate, visionary action. At the core of this threshold lies a profound ethical imperative. Previous civilizations often failed not because they lacked technology, but because they neglected the responsibility that comes with it. Weapons of mass destruction, unchecked environmental exploitation, and social inequalities contributed to collapses that erased millennia of progress. Humanity now faces the possibility of making similar errors on a global scale, yet we also possess the awareness to prevent them. This self-awareness, our ability to reflect, anticipate consequences, and plan deliberately, is the most crucial tool we have inherited from the lessons of deep time. The technologies left behind by previous civilizations offer both solutions and caution. Climate engineering blueprints, resource management systems, and energy technologies demonstrate that it is possible to maintain planetary stability while supporting technological growth. Quantum consciousness storage systems and interstellar communication protocols reveal that intelligence itself can be preserved beyond the fragility of biology. Space-based monitoring networks show that even planetary-scale threats, such as asteroid impacts or solar radiation events, can be mitigated. Each of these systems represents a fragment of a civilization that faced challenges not unlike our own, survived through foresight and integration, and left a legacy intended for future generations. Yet these gifts come with profound responsibility. Integrating knowledge with ethics, technology with sustainability, and innovation with foresight requires humanity to mature socially, morally, and culturally.
It requires us to think in terms of millennia, not decades, to prioritize global collaboration over narrow self-interest, and to recognize that intelligence is not merely a tool, but a responsibility. We inherit a world shaped by countless civilizations before us, yet our era represents the first opportunity to consciously choose sustainable, ethical, and lasting progress. The window for this choice is now. Accelerating technological development, environmental change, and global interconnectedness mean that decisions made today will echo through centuries. Whether in energy policy, climate action, genetic and biotechnological innovations, or emerging quantum technologies, the frameworks we establish will determine our capacity to endure. Civilization is at an inflection point. Minor miscalculations could cascade into irreversible crises, while visionary stewardship could establish a sustainable technological culture capable of thriving across millennia and even across the stars. Consider the possibility that the universe itself has set conditions for the rise of intelligent civilizations and their ethical maturation. The evidence suggests that intelligence and consciousness are fundamental forces, capable of shaping matter, energy, and evolution on cosmic scales. Life on Earth has repeatedly produced intelligent species. Humans may be the culmination of a long sequence of experiments, successes, and failures. This perspective shifts our responsibility from local survival to cosmic stewardship. Our choices are no longer merely about prosperity or security. They're about whether intelligence, knowledge, and consciousness can endure in the universe. Ancient guardian systems, consciousness preservation technologies, and interstellar communication networks hint at a broader community. Humanity may not be isolated. We might be part of a galactic society that has been monitoring, guiding, and testing civilizations for eons. Our ethical, technological, and environmental decisions could determine whether we qualify for inclusion in this interstellar community. Success would grant us access to advanced technologies, knowledge networks, and partnerships that amplify our ability to survive and thrive. Failure could relegate us to the historical patterns observed in the geological record, an intelligent species lost to time with only faint traces remaining to be discovered by distant successors. This is both humbling and exhilarating. We are the inheritors of knowledge accumulated over millions of years, the recipients of wisdom painstakingly encoded in matter, energy, and consciousness itself. Yet we are also the authors of the next chapter. Every technological breakthrough, every societal reform, every act of stewardship or neglect will shape the trajectory of human civilization and the legacy we leave behind. The responsibility is immense. The stakes are cosmic, and the opportunity is unique. Humanity stands at a threshold unlike any other. The threshold of sustainable technological civilization, cosmic stewardship, and interstellar participation. We must decide whether to rise to the challenge or falter as our predecessors did. The choice is ours, and the time to act is now. The legacy of deep time, the guardians of the past, and the blueprint of future possibilities converge at this moment. By understanding, integrating, and applying the lessons of the Silurian Hypothesis, humanity has the chance to achieve what no previous civilization could: enduring, ethical, and conscious mastery over technology, environment, and destiny. We are not alone. We are not first, but we may become the first to learn, to act, and to endure. The cosmic library of intelligence, consciousness, and technology awaits our response.
As we stand at the edge of the unknown, one question becomes undeniable. What will we do with the knowledge and guidance left by those who came before? The evidence is clear. Earth has never been the starting point of intelligence, nor the sole witness to technological achievement. Across millions of years, civilizations have emerged, reached unimaginable heights, and vanished, leaving only fragments, messages, artifacts, and systems designed to guide successors towards sustainable survival. Now, humanity holds that same inheritance in its hands. The Silurian Hypothesis is more than speculation. It is a roadmap etched in stone, ice, and quantum fields. It is a warning and an invitation. warnings of collapse, extinction, and the consequences of hubris. Invitations to rise, to build, to learn, and to endure. The guardians of the past have provided every tool we could need: technologies to stabilize the planet, blueprints for sustainable development, methods to preserve consciousness, and guidance systems designed to steer civilizations through crises. Yet these tools will only serve us if we understand their purpose, respect their lessons, and integrate them wisely into the fabric of human society. Our civilization is accelerating at an unprecedented pace. Artificial intelligence, biotechnology, quantum computing, space exploration, and climate engineering are converging to reshape our planet and our destiny. Each advancement carries immense promise and immense risk. Previous civilizations demonstrate a harsh truth: technological capability alone does not guarantee survival. Wisdom, foresight, ethical governance, and sustainability are the pillars upon which lasting civilizations are built. Without them, even the most advanced societies succumb to collapse, leaving only whispers in the geological record. Now, humanity has the unique chance to break the cycle. Unlike predecessors, we are aware of their patterns, successes, and failures. We can analyze the signatures of past collapses and the traces of their technological brilliance. We can study consciousness preservation systems, planetary guardian networks, and interstellar communication protocols. We can learn to avoid environmental overexploitation, social unrest, and the misuse of technologies that could destroy us. This is an opportunity no civilization before us has ever had. But the responsibility is immense. The Silurian Hypothesis teaches that intelligence and consciousness are cosmic forces with the potential to shape entire worlds. Our decisions now will determine not only the fate of humanity, but the preservation and extension of intelligence itself on Earth. We can choose to advance responsibly, integrate the wisdom of the ancients, and create a civilization capable of enduring beyond our planet. Or we can repeat the cycles of the past, leaving Earth as another failed experiment in intelligence, its story recorded only in the traces of vanished civilizations. The evidence suggests that ancient guardian systems are still observing, still guiding, still waiting to see whether we are capable of acting wisely. They may intervene to prevent catastrophes, but ultimate responsibility rests with us. This is humanity's threshold, a moment when awareness, technology, and ethical choice converge. The window may be measured in decades, but the consequences will echo for millennia. Our actions in this pivotal period will determine whether human civilization becomes the first to transcend planetary fragility or another entry in the annals of lost intelligences. Imagine a future where humanity rises to the challenge, a civilization that harmonizes technology, ethics, and sustainability, that preserves consciousness and knowledge across deep time, that participates fully in a galactic community of civilizations, that safeguards Earth and beyond from the perils that doomed its predecessors. Such a civilization would honor the legacy of deep time, completing the work that those who came before began, and proving that intelligence can endure. The choice is ours. Every innovation, every decision, every act of stewardship is a vote for survival or collapse. Humanity is not alone, not first, but it may be the first to learn, to act, and to endure with awareness. The past has given us the tools and the lessons. The future is ours to shape. We stand at the threshold of history, on the brink of a chapter that will be written in the stars. The universe is watching, deep time is waiting, and the story of humanity, whether as a fleeting spark or as a lasting light, will soon be told. As we reach the end of this journey through time, space, and intelligence, one truth becomes unavoidable. Humanity is standing at a crossroads unlike any before. We are inheritors of a world shaped not just by natural forces, but by civilizations that came before us. Civilizations that mastered technologies, traversed the stars, preserved consciousness, and then vanished. Their story is etched into the rocks, ice, oceans, and even the quantum fields of our planet. And now, their legacy has fallen into our hands.
The Silurian Hypothesis forces us to confront a profound reality. We are neither the first to reach technological heights, nor the only ones capable of shaping the future of intelligence on Earth. But unlike our predecessors, we have a unique advantage. We can see the patterns of success and failure across deep time. We know the consequences of unchecked advancement, environmental neglect, and social collapse. We have the knowledge, tools, and awareness to avoid repeating the mistakes that doomed civilizations before us. This is the moment to choose wisely. Humanity can embrace sustainable technology, develop resilient societies, and preserve knowledge and consciousness across generations. We can participate in a cosmic tradition of intelligence that extends far beyond Earth. Or we can ignore the lessons of the past, pursue short-term gains, and risk becoming another vanished civilization. Our achievements buried in the geological record, waiting to be discovered millions of years from now. Every decision matters. Every innovation, every act of stewardship, and every choice about how we interact with our planet and each other will shape the legacy we leave behind. The ancient guardians may guide us, but they cannot replace human wisdom, ethics, and courage. The responsibility and the opportunity rests with us. If this journey through deep time has sparked your curiosity, consider what you can do today. Explore, learn, and share knowledge. Support sustainable technologies, question assumptions, challenge yourself and your communities to think long-term. Humanity's survival may not depend on any single invention, but on a collective commitment to responsibility, understanding, and care. The story of previous civilizations is not just a warning, it is an invitation to rise above our limitations, to honor the lessons of the past, and to become the first civilization to achieve lasting technological and ethical maturity on Earth. We have been given a rare gift, the accumulated wisdom of millions of years. The question is simple: will we use it? If you found this exploration as mind-expanding as I hope, hit like, share it with others who are curious about our place in the universe, and subscribe to the channel for more journeys into science, history, and the mysteries of civilization. The universe is waiting, and the story of humanity is still being written, one choice at a time. Remember, deep time does not wait. The opportunity is now. The choice is ours.